We're going to practice writing inequalities in the three different notations: set notation, interval notation, and graph notation. Our first example is to write the inequality x is greater or equal to 20. First, we'll write it in set notation, curly set bracket, all real numbers x, and the bar that I just put, the vertical bar, means such that. So this reads as all real numbers x such that x is greater than or equal to 20. Then close your curly set brackets. So that says all real numbers x such that x is greater than or equal to 20. We just put those curly set brackets around the expression. Now let's express the same set of numbers, all the numbers greater than or equal to 20, in interval notation. Well, we're going to start with the smallest number in the list, which is 20, and then comma the largest number in that list. Well, the largest number, if it's every number greater than or equal to 20, well, it's getting pretty close to infinity. Now we're going to put a boxy bracket for the 20 because there's an equal portion in the inequality that says greater than or equal to 20, so we're including 20, but we never include infinity, positive or negative, because it's not even a real number. We don't actually reach it. So always put an open round bracket next to your infinities. Last method is to write our solution in graph notation. So here's the x-axis. I found the important number 20. I'm going to include 20 and shade every number that's greater than 20. Okay, let's do another one. We are going to take negative 13 is less or equal to x is less or equal to 5. Ooh, okay, so we've got the x in the middle. We've got some numbers on the left and right. Set notation, curly set bracket, all real numbers x, then the bar that means such that. Okay, the smallest number will be listed first. It's negative 13, and then they said less or equal. So write the less than or equal symbol to x, and then they say less or equal, put the less than or equal symbol to 5, and then close your curly set bracket. Okay, there it is. That says exactly all real numbers x such that negative 13 is less than or equal to x is less than or equal to 5. For interval notation, list the smallest number in this set, that's negative 13, comma, and then the largest number, positive 5. Include negative 13 because there's an equal portion in the inequality right near negative 13. And the same for 5. Include 5. So you're putting boxy brackets on each end because there's an equal portion attributed to each of these values. And then finally, let's write this set of numbers in graph notation. Here's the x-axis. The pertinent numbers are negative 13 and 5. We're going to shade everything in between negative 13 and 5, and we're going to include 13 and include 5 since there were equal portions in their inequality. We're going to include those with boxy brackets. Be sure to shade in the middle. Now, I just want to say that when you have this type of inequality that has x in the middle, a number on the left, a number on the right, and the two inequality signs are always pointing in the less than direction when you have it in standard form. This type of inequality with the x in the middle, it's called a compound inequality. Part C, we'll write x is less than negative 2, or that means union, x is greater or equal to 12. Okay, let's write this in the three notations. First, set notation, write your curly set brackets, start with all real numbers x such that x is less than negative 2. Now the word or, we're going to use the union symbol, the U, and then write x is greater than or equal to 12, curly set bracket. Interval notation, well, we've got two intervals that are glued together with the union symbol. So we'll have to express each of these in interval form and glue them together with the union symbol. First, x is less than negative 2 means that all numbers less than negative 2 will be in this list. So the smallest number of the set of all numbers less than negative 2 starts with negative infinity, comma, and the largest value in that set is negative 2 itself. Now we have an open bracket on negative infinity because we never use boxy brackets on infinities. We have an open bracket, a round bracket, on negative 2 because there is no equal portion in this inequality, x less than negative 2. Now we're going to union that together with the interval form of x values that are greater than or equal to 12. Well, the smallest value in that set would be 12 itself, and the largest would be infinity. Boxy bracket on the 12 because of the equal portion in the inequality, but round bracket on infinity because we always use round brackets on infinities. The graph, well, we're going to have a split interval in this situation. We're going to shade everything that's smaller than negative 2, round bracket, because we're not including negative 2. And then we're going to shade everything greater than 12, boxy bracket, because there was an equal portion, and we are including 12. And this type of inequality, which you see has got a big gap in the middle, we call that a split inequality.